Welcome to Cycode's Shift to AI demo webinar. I'm Devin McGuire, Product Marketing Manager, and joining me are Nofar Hatchman, Lead Product Manager, and Brian Levine, Product Security Solution Engineer. Nofar, Brian, thanks for being here. We'll spend most of our time in the actual demo, but first I want to define kind of what we mean by shift to AI. So shift left is something most of us are familiar with. It really focused on how do we react sooner in the software development lifecycle to prevent human-generated vulnerabilities from reaching production. But the development lifecycle has changed. Humans now set the intent for AI agents to generate the output. And risk is getting introduced before code is even created, when developers submit a prompt with a secret or connect to a malicious MCP server or AI skill. And security must adapt to actively govern and control the inputs of agentic development, not just reactively secure the outputs. This is what we mean by the shift to AI. It's about securing new AI risks and new AI attack surfaces in a new agentic development lifecycle, or the ADLC. So, Nofar, with that, I will hand this over to you as the lead product manager on Cycode's ADLC security to walk us through really how Cycode is approaching this need.
And before we show you the product, I want to explain what ADLC security is. So the way we build software has changed, and security needs to change too. For the last 20 years, we have been protecting the SDLC, the software development lifecycle. And the rules were simple. Humans wrote the code, we knew what tools they used, we knew what risk to look for. We caught problems in CI after the commit, and all of that worked. But today, AI is writing code alongside developers. Tools like Claude Code and Copilot, MCP servers connect those tools to GitHub, Jira, and even your databases. AI rule files inside the repo tell the AI how to behave, and models are pulled from Hugging Face. And this is the hard part. None of this is being approved by you. Developers are picking their own AI tools every single day, and the toolchain isn't fixed anymore. It's changing all the time. So we started thinking about this differently, and we call it the ADLC, the Agentic Development Lifecycle. It's not just a new name, it's a new approach, because now there is risk in the prompt itself, risk in what the AI reads, risk in what an AI agent decides to do for you. The old playbook doesn't cover any of that. And that's really what today is about, how we secure software in this new world. So this is how we think about it at Cycode. ADLC security in 4 pillars, and they actually tell one story together. You start by seeing what AI you have, you decide what's allowed, you shape what the AI does, and you catch what risk it creates. The first pillar is AI visibility. This is where you start. You can't make any decisions about AI if you don't know what's already there. And there are 2 sides to this. There is the developer surface, how AI is impacting your developers, the coding agents they are using, the MCP servers they have connected, the AI rule files they have added to the repos. And then there is the product surface, how AI is impacting what you are shipping, the models you are calling, the AI libraries in your dependencies, the AI secrets in your code. Cycode automatically finds all of it, and we don't ask developers to tell us. We look at the traces this tool leaves behind, and by doing that, we create a single inventory for both sides that is always up to date. The second pillar is the AI governance. Once you can see it, you can decide what's allowed. Most companies already have an AI policy somewhere. The problem is, having a policy isn't the same as enforcing one. With Cycode, every AI tool in your inventory becomes something you can actually act on. You can approve it, block it, or change your mind later, and the platform handles the rest. That's how a policy actually becomes enforcement. And then, of course, we have the AI guardrails. Now you know what you have and what's allowed, but AI is making decisions in real time. Every prompt, every file it reads, every action it takes. So you also need to influence those decisions as they happen. That's what guardrails do. Cycode plugs straight into the AI agents and steps in at the moment that matter, before a prompt is sent, before a file is read into context, before a tool runs. If something risky is about to happen, a secret about to leak, an unauthorized action about to be taken, we stop it in the moment before it ever leaves the developer's machine. And finally, we have the AI risk detection. Even with everything else in place, AI is still writing code, and that code has its own risk. Things like prompt injection, leaked AI secrets, vulnerable machine learning libraries, and the OWASP top 10 for LLM. We bring all of them together into one place, a single ADLC security category with one risk score. So you can finally answer the question, how exposed are we to AI risk, and what do we fix first? And that's really the whole idea. You see what AI you have, you decide what's allowed, you shape how it behaves, and you catch what still gets through. And now, let me bring this all together and show you what it actually looks like in practice. 1. You see every AI tool in your ADLC. Automatic continuous detection into an inventory that's always up to date. 2. You turn that inventory into a policy you can actually enforce. You can approve it or block it with one click. The platform handles the violations and the cleanup for you. 3. You stop the risk at the moment it happens, right where the AI is making decisions in real time, before anything leaves the developer's machine. And 4, you find AI-specific risk all in one prioritized place. So that's ADLC security, one platform that covers the full agentic development lifecycle. And now I will hand it over to Brian for the demo.
Thanks, Nofar. Thanks, Devin. Now I'll show the 4 pillars in practice. So agentic engineering is enabling developers to generate value and ship code updates faster than ever. For the demo, I'll walk us through a few scenarios that highlight how Cycode tackles risks in AI development without disrupting the engineering workflow. So to begin, I'm going to walk us through a scenario. I'm a site reliability engineer building an automated AI-powered incident response system that will ingest alerts and trigger remediation scripts on our environment. So I'm going to start in a cursor session with a project outline and a prompt to my agent. And we'll show how Cycode scans as the agent is developing code. So here we see the prompt to write a Flask service to perform this action. I enter the prompt and the agent begins writing code. Now to illustrate, I'll show how the agent calls Cycode and runs the scans. So the agent generated the files. We see the incident handler, requirements.txt, Docker file, and now it's calling Cycode. So we see where the agent is calling Cycode directly and getting results back. We see that Cycode found 1 SAST finding and 2 secrets finding. The agent now takes those results, fixes the code, makes a code update, and submits it back to Cycode to be scanned again. Runs it again in Cycode, and now the findings are resolved. Now it runs the SCA scan. So it continues in this loop, generating code, calling Cycode to test it, and then remediating it until it's done, and then checks in the code. So here we see a full summary of everything Cycode caught and what was remediated by the agent before it was submitted. So we're not just detecting problems, the AI coding tools are calling Cycode on their own, checking their own work, and fixing problems directly inside the developer workflow. Now, while all this action is going on, while I'm building this tool, I am an SRE and a few alerts have come in. So I'm going to jump on those and help the team out. So the first case is a teammate slacked me about an AWS Lambda error they're seeing. So I'll drop that into my Claude Code session to begin debugging the issue. So here I have the message that I received in the alert and the Slack message, and I copy that into my Claude session. Cycode detects that there's a secret in that prompt and blocks it. So here we see there was a critical secret. Cycode detected it, blocked it, and gives me as the engineer a notification how to move forward. So I can remove this secret before sending, and then I can move forward. So the secret was blocked, it never left my workstation, it was never shared publicly with an LLM. And while that Lambda fix is brewing, my pager duty goes off again, and we have a staging server down. So again, I'm going to go to my Claude Code session and begin debugging this issue. So the staging gateway is down. I copy paste my alert. I begin debugging this issue. But look, Cycode detects that there's a file read happening, which is a sensitive file, a server PEM, which has a secret key in it, and Cycode blocks it. But the agent recognizes this and continues to offer advice and guidance on how I can debug this issue without blocking my work. So this is the file read boundary and the prompt boundary. AI guardrails detects the risk, blocks it, but does not block the developer from moving forward. Now I'm going to shift lens and show you what the security team is seeing this whole time while this interaction is going on. So here we are in the AI interactions page. I can see all of my developer activity and really anyone that's using any Claude Code or Cursor tool across the enterprise. We can see exactly what's happening. So here we see an overview of the actions: blocked, reported, allowed, and the scan results. So everything that is blocked, like we just saw, are secrets and prompts, file reads, MCP issues, and other events are blocked in real time. Other things that we just want to report on but not blocked are reported. And so they may be allowed, but then reported. And then also we have 30,000 allowed normal everyday activities that have no security risk, but we still want visibility on that so we can investigate it later. So let's drill down a little bit deeper into some of the blocked issues. Here we see the secret and prompt that we just performed. We see the file read that was just blocked. And let's dig down a little bit deeper into an MCP call. So here I have an MCP execution. I can see who the user was, what model we were using. I can see that the agent tried to call an MCP server and which tool call they made and a violation that was passed in the parameter of that MCP call. So in this case, we see a stripe key and we can see exactly what was in the prompt and what was in the tool call and that it was blocked. So the Cycode guardrail intercepts it at all three surfaces: prompts, file reads, and MCP tool executions without blocking the developer. Now let's zoom out a little to the organization level and see what the AI bill of materials looks like. So most security teams really can't answer which AI tools are running and where are they and who's using them. Cycode automatically detects all of the infrastructure components, all of the AI components, and catalogs them for us. So this is continuously and dynamically updated in real time as new infrastructure components are detected. So here we can see things like AI infrastructure, like Light LLM, Hugging Face, other components, Vercel. We can see the models that are being brought in, which coding assistant tools are being used, AI secrets, packages, and other details. Now, as an admin, I want to drill in a little bit to this Atlassian MCP server. So I'm going to click down into the Atlassian, and here I see the MCP server and exactly where it's being brought into our code. I can see which organization, which repo, and the actual file that defines this MCP server and where it's being brought in. So now instead of being hidden, I have visibility on where these files reside, who's bringing that in, and we can also decide our security posture and security policy on that. So here we see authorized. This means that here we see unauthorized. This means that a security administrator reviewed this and marked it as unauthorized. So any cases where this is brought into the code or called will throw a violation that we'll see here in a second. So the visibility shows us what's in the code. And as we scroll down, we can see exactly where it's being used and who's calling it. So Cycode integrates directly to coding platforms like Cursor and Claude Code at the enterprise level. So we can show you lines generated at the enterprise level and at the individual user level, how many lines of code have been generated. We can see the acceptance rate at the organization level and the individual developer level to see how they're using Claude Code and how much of that code is being brought in, or Cursor, or other tools. And here below, we see, again, an overview of the MCPs that are being called in and which models are being leveraged. So we have full visibility on the AI bill of materials, no more shadow AI. And so I'm going to drill down just a little bit deeper now into the inventory and show you how we expose the fine-grained details of these infrastructure components. So under inventory, we have infrastructure, coding agents, things we saw a minute ago, but also even things like skills and rule files and where those are being brought in. So skills and rule files, they govern the behavior of agents as they're working in our code. So they're effectively unreviewed code that's part of our software supply chain and also bringing in risk. So now we have visibility on where these rule files exist, where these skill files exist, what's defined in them, and who's using them. Now we can layer governance on top of it. So to highlight the governance piece, we have MCPs and models. Every new model and every MCP that is detected automatically gets an authorization status. So here we see for MCPs and models, we see the authorization status. So in the example we showed a second ago, Atlassian is unauthorized. Anything new that hasn't been reviewed yet is in the not reviewed state. So when we set the status and the authorization status, that will throw violations anytime that component is used or called. And those violations are surfaced directly the same way all of the other violations in our platform are viewed, with the same workflows, the same patterns, the same SLAs. So your team can use the same tools to see which AI components are being brought in violation of the policy. We can see the tool name, the category, and exactly where that's being brought in. The AI risk dashboard gives us another view to show us in real time which AI risks are most urgent right now. So right at the top, I see a threat update about the light LLM package breach that's an ongoing campaign. This is not only telling us that an alert exists, but it also notifies us in the repo where we may be affected by that issue. Also, as I scroll down, I can see which projects with AI have the highest risk and which repos with AI have the highest risk. So when leadership wants to know where is our highest exposure and where should we focus, the answers are here. So that's the full picture, the visibility to see your AI, the governance to control it, and guardrails to prevent it at the source. Also, the risk detection to catch what's live in the environment. Now I'm going to showcase two more examples of how we can get preventive and get proactive about addressing these risks. So first, instead of just flagging risky tools and code, Cycode now can investigate the repo and actually write rules that prevent them in the first place. So here I have a repo with hundreds of violations, and I'm calling up Maestro, our AI orchestration agent. And I ask it to analyze these findings and then generate a rule file that will help us stop making these same violations and same vulnerabilities when other agents are generating code. So I can see the thinking and the analysis and the output right here. So it's actually investigated the details of the repository and seen which violations are most frequent and where are they occurring. So it's giving us very specific guidance to hand off to the agents, things like not putting secrets in configuration files and which files they're appearing in this repo. Also things like not pinning dependencies, all the way down to infrastructure as code rules for things like Kubernetes and Docker. So now all I have to do is take this agent MD, drop it into my repo, and all my new agent sessions will automatically incorporate these rules as they're generating code. And finally, I'll switch back to our SRE to show how we can bring the Cycode context intelligence graph directly into our AI agent tools that developers are using. So again, I'm the SRE, and if you recall, on the risk dashboard, the engineering productivity project was one of the highest risk projects. So I really want to get a better look at what's going on there. So as the SRE, I'm going to just call Cycode directly from within my Claude session and say, use Cycode to give me the security posture for this project. So now the agent calls Cycode directly and gives me an analysis and a summary of the violations found in the repo. And so here we see a summary of the findings, but also what is the top risk. You recall the secret leakage was a critical problem, and the agent is now surfacing that to us here, saying, okay, yep, the Stripe web secret, that's the highest risk. Here are some other similar vulnerabilities and findings. I would prioritize that first. So we bring the full context intelligence graph to run full queries and intelligence in the AI agent in the workflow. So this is what the shift to AI is all about. Security doesn't wait at the PR. It doesn't wait at the pipeline. It has to move to development in the AI layer in real time as code is being generated. Now back to you, Devin.
Cool. Yeah, thanks, Brian. I mean, that's really cool to see it in practice. You know, Nofar kind of laid out those 4 pillars of how do we get visibility over our AI technologies, have governance, and then use that governance to actually establish guardrails within the developer workflow, looking at risk detection and managing that all within one platform. Obviously, like things are moving really fast, and you're even showing things that are, you know, like using Maestro for the AI rules file and bringing Cycode context into 2 agents in those development workflows. So really, really exciting to see this pace of innovation. There's obviously so much more to dive into and share. So I'll just say for anyone watching, if you want to go deeper, if you want to explore how this applies in your specific organization or use cases, please reach out, schedule time to connect. We would love to talk and connect about this. For now, though, I'll say thank you, Nofar. Thank you, Brian, for sharing more about ADLC security, what this shift to AI looks like in practice, presenting the demo. So thanks everyone for joining, and we hope you have a great day.